Today in class, we're going to work on lesson 7.2. We're going to be writing and graphing equations. Yesterday, we talked about linear relationships, and we said that those would always follow a pattern, or they would make a straight line. On your notes handout, the first example says a bicycle rental company charges $18 to rent a bicycle, plus $7 for every 2 hours you keep the bicycle. So underneath we have a table, and it's going to show us that we need to find the prices for 0 hours, 2 hours, 4 hours, 6 hours, and 8 hours. Let's look up in the question and take out the important information. The first number I see is $18. And when we read the question, it said the company charges $18 to rent a bicycle. It doesn't say anything in this section about per hour, every hour, each hour. It just says they charge it. So that's going to be like our one-time fee. You're going to have to pay this $18 just to get the bicycle. So when we look at our table, at 0 hours, I'm going to have to pay that $18. So I'm going to go ahead and fill in my table showing that I'm already paying the $18. When you keep reading the question, the rest of it says, other than just this $18, I'm going to have to add $7 for every 2 hours I keep the bicycle. And our table is already counting by twos for us, so this is going to work out great. I'm going to highlight or circle or box that important information. And now I know for every group of 2 hours, I should just add $7 more to what I previously was charged. So when I go down from 18 to my next row in my table, I should just add 7. 18 plus 7 is 25. I need to keep doing the same pattern again. Add $7 more. 25 plus 7 is 32. 32 plus 7 is 39. And 39 plus 7 is 46. All right, so now in our table, we can look back. 0 hours, I pay the $18. After I keep the bike for 2 hours, that charges $25 total dollars. 4 hours, I have $32. 6 hours, I pay $39. And 8 hours, I pay $46. The thing we haven't done yet is write an equation. So if I wanted to find any amount of hours, okay, now what we want to do is write that equation. And any amount of hours, I can use this same equation to tell how many dollars I pay. Our table is counting by twos. So if I keep counting by twos, I can just use adding $7 every time. But let's say I only wanted to keep the bike for 1 hour. I need to know how much does 1 hour cost to rent the bicycle. If 2 hours over here costs $7, 2 hours costs $7 extra. 1 hour would just be half of that. So 1 hour is $3.50. Because if I wanted to know 5 hours of keeping the bike, I couldn't add 7 more because it says 7 for 2 hours. So when you look down here at the bottom, your equation, I'm going to start, all of our equations need to be written like this. Y equals a number, I don't know it yet, times however many hours I'm going to keep the bike, plus the fee. Now these letters represent the numbers we're going to put in. So when we look back at our question, it says our fee is $18. So I am going to put an 18 in the place where that letter B is. And it said I'm plussing it. The letter X is going to represent how many hours I keep the bicycle. And the letter M is going to represent how much does only 1 hour cost. So I'm going to put in $3.50. And all of that is how I would find out Y, which is this column in the table of how I find out my total amount of money. Okay, now we're going to take our information from our table that we just got through making, and we're going to graph it. So when we look at our table, we can think about this first column right here for our hours. We're going to think about that as being our X when we graph it. And we're going to think about the column that's our money as our Y value. Now you can also look over here at your graph, and on the x-axis, it even says time. On the y-axis, it says cost. To know where to put the dots, we're going to look at each one of the pairs like you would graph it. So normally you have ordered pairs, and it would say 0, 18, and then I would graph it. And then the next row would be 2, 25. So that's how I'm going to go through this process. My first one, 0, 18, I'm going to come over to my graph where the 0 is on the x-axis, and I'm going to go up to where I think 18 is. This graph is counting by tens. Every box is worth 10, so I'm just going to estimate where I think 18 is. I think 18 is going to be just a little bit under the 20. Then I'm going to the next pair. In my table, it says 2 hours matches up with $25. So again, I'm going to go to my graph. I'm going to go over to my x-axis where the 2 is. So be careful because this first line is not 2. The second line represents 2. And it matches up with 25. So I'm going to be at 2. I'm going to go up to where I think 25 is, which should be perfectly between 20 and 30. And I'm going to put a dot there. I'm going to continue the process down the table. 4 hours is supposed to be $32. I'm going to go on my x-axis over to where I see a 4. I'm going to go up to where I think 32 might be, barely above the line that stands for 30, and I'm going to put a dot. The next row says 6 hours, matches up with $39. Go on my x-axis over to 6. And I'm going to go up to where I think 39 is, which should be barely under the line for 40. And I'm going to put a dot there. The last row for me says 8 hours is $46. So again, go on your x-axis to where you see 8. Go up to where you think 46 might be, which is a little past halfway between 40 and 50. And then because I'm estimating, I don't have these dots in the perfect section. So I'm just going to connect them in the best line I possibly can. Okay? And that's how I would graph it. We said yesterday that linear relationships, they should make a straight line. So in my graph, I should have a straight line the best I can. Or they follow a pattern. So in our table, our pattern was $7 for every 2 additional hours. Example 2 on your paper, all we have is a story problem. And we just need to write the equation based on what's in the problem. And then I'm going to find a random quantity that I could calculate from my equation. When you read this question, it says, the temperature of a pot of water is 45 degrees. The temperature increases by 20 degrees per minute when the water is being heated. What would the temperature of the water be after it was heated for 6 minutes? I'm going to go to my problem and I'm going to see the important information. So right now, in the first sentence, I know that the temperature is 45 degrees. That's what it's going to start at. Now, if we think about this, from previous problems, this would kind of represent our phi, what's going to happen no matter what. Then as you read through the rest of the problem, it says the temperature is going to increase. So it's adding, and it's going to add 20 degrees per minute. So every minute I have this pot of water cooking, I'm going to add 20 more degrees. We said our equation should start like this. Y equals a number, I don't know what it is, times, for us, however many minutes, plus the temperature that's already there. When we look at this question, it said the temperature we already have is 45 degrees. So I'm going to put 45 degrees at the end. No matter how many minutes I boil the water, it started at 45 degrees. So that has to be there. And then it says I should add, so I have my plus sign. I'm going to add 20 degrees per minute. So since it says per minute, that already tells me how much 1 minute is worth. So I can put 20 degrees times however many minutes I cook the water. And all of that will equal the new temperature. That's going to be my equation. Y equals 20x plus 45. If you look at the end of the problem, it says, really, I want to know the degrees after 6 minutes. Yesterday, we were working with riding rides, and they cost $2 per ride, plus the admission to get into the carnival. So this is very similar. If I look at the equation, or I can think about the problem in general, the water temperature is already 45 degrees. I can either keep adding the number 20 6 times, or I could just figure out in my brain what is 20 times 6. 20 times 6 is 120. So altogether, that's going to be 165 degrees. So my answer for 6 minutes is 165 degrees Fahrenheit. Example 3 is the same type of setup. The question says a pine tree is planted when it's 24 centimeters tall. It grows at a rate of 3.2 centimeters per week. How tall will the pine tree be in 8 weeks? So again, the question wants me to make an equation. Once I know the equation, I am going to change it. And this says 6 minutes, but actually it should say 8 weeks. So I'm going to cross that out. 8 weeks. Because that's what it tells right here. All right, the important information says that the tree right now, it is 24 inches tall. This is going to be my starting amount for the tree. And as you keep reading the problem, it said it's growing. So that means I'm going to add 3.2 centimeters per week. So this lets me know how much taller it's going to get for 1 week, and I'm going to keep adding that in a table. Our equation needs to start out like this again. Y equals a number I don't know times, in this question, how many weeks the tree is growing plus how tall the tree started with. So now I'm going to go back through my problem, and I'm going to insert the numbers that it gives us. I'm going to insert 24, and I'm going to insert 32. M, where I have the M, was how tall it's growing per week. So that was 3.2 times however many weeks it grows, plus the amount the tree was when it first started growing, which was 24 centimeters. And all of that is going to tell me how tall the tree is for how many weeks I want it to grow. And in this problem, it says I want it to grow for 8 weeks. I don't know 3.2 times the number in my brain, So I'm going to have to work it out. We want it to grow for the 8 weeks. So 3.2 times 8. 8 times 2 is 16. 3 times 8 is 24. Plus 1 is 25. Okay, it's not going to be 256 because I have this decimal in my problem. So I'm going to have to add it in between the 5 and 6. So right now, this tells me that the tree is 25.6 centimeters. That's how much new growth the tree had during the 8 weeks. And I have to remember to go back and add the 24 inches that it was when it started. Plus 24. And 24 is a whole number, so I need to make sure I put in that decimal and add my 0 so that those line up perfectly. Now I can add it together. 6 plus 0 is 6. Bring down my decimal. 5 plus 4 is 9. And 2 plus 2 is 4. So now I have a perfect answer for the tree growth in 8 weeks. It is 49.6 centimeters tall.